This is the simplest practical came out in the examination, Cambridge examination. Okay, so it is, can you see here? November 20, November 10, November 20, November 10, paper 33. Okay, so this is simple pendulum, and you have to keep h constant and to vary, to keep, so you do not change the height of the stand. It should be the maximum height because h should be as large as possible. So we keep h constant, and then we increase x. We start from 5 centimeter, about 5 centimeter, and we increase it. Okay, so x will change. So for every x, we are going to have a time for one oscillation. Okay, now let us see the practical in more detail. Now this is the setting up of the apparatus. So this is my stand, the fret. The stand is high. You can see it. Okay, high as possible, and I have measured the distance from the stand here to the pendulum bob, to the table, from the table to here. It is h. So h is from the bench to the clamp here. So this is h. We do not change h. My h is 81.4. So we have to adjust x approximately to 5 and to make simple oscillation. Now the oscillation, when you oscillate, take this like that. Then you don't start your stopwatch here. You wait when it is back here, then you start your stopwatch. Look here. Start. 1, 2, 3, 4. I repeat. Now, do not stop. Do not start your stopwatch here. It will go, when you will release this, it will go there and then come back. When it come back, you start. When it come here again, then you count 1. So let us begin. Do not start, okay? Start. 1, 2, 3, 4. Okay? And you change the value of, this value is 5. So you change the value of x. This is x. This value, you change it so that you have 6 values of x. You do not change the height of the stand. Now, if you take the meter rule here to here, it is about, can you see it is about 80? Okay. Now, when you will change the value of 5, do not change it by 5. So it will one reading at the bottom here, one reading here, one reading here, one reading here. Not good. You have to take the whole height. Okay. Then the height x should be from 5, about 20, about 34. We have 3 here, 3 readings here, about 60 here, here. Okay, so you divide the ruler by 2. Wait 1 minute. So this is the height h, x. This is the height from the bench to the clamp. So this is 5. Okay, you you take one reading here. You take one reading here. So you loosen the clamp, and then you pull the thread up. The bulb will move up. For here you take one reading, two reading, three reading, four reading, five reading, and six reading. So it should cover the whole length of the height h. Okay. For example, I have done this 0.05. Now, when I have taken the reading here, I have taken the reading in centimeter for h and for x. Now, never put x. Now you have to change x, okay? But never put x in centimeter in the table. In the table, you put meter, okay? Now, second page, display the bulb and then record the value, an accurate value of t. So you take 20 oscillation, first oscillation, second oscillation, and then you average the two results. Then you add these two, you divide by 2, you will get this. And then you divide by 20, you will get your oscillation. Okay. Now, keep h constant. Therefore, you have to keep this height constant. Okay. And then change x. Repeat and have 6 sets of values. So I have already done with 5. Okay, I have already done with 5. I got 1.7. So with 5.5 centimeter, we divide by 100, it is 0.055. You convert centimeter into meter, you put in the table. Then you do the oscillation, the average, t, you divide this value by 20, you will have t square, you square this one, you will get this. And then you continue like that, okay? So my second reading is of x is 17 centimeter. Then become 29 centimeter, then become 41 centimeter, 53 centimeter, and 65 centimeter. Okay, so these are my, this is how I arrange the table. Number of oscillations, x, which is in meter, t1 second. If you have written centimeter here, you no mark, you will not lose mark for that. So I prefer to put meter, okay? If your teacher at school tell you to put centimeter here, because all measurements are done on centimeter, you put centimeter. You always listen to your teacher at school, okay? Now it is x here, s here second, so average, and then t, and then t square. You square this value. Yeah, make a mistake. When you make a mistake, do not correct on the figure. You just cut it and put it on the top. Okay. Now you have to plot a graph. Now I have to plot a graph. How to plot the graph now? 1 minute. Sorry. How to plot the graph? 1 minute. The problem to calibrate the camera. Now, you can see here, I have chosen a scale of 0.09, 0.09, 0.09. Why? Because my reading for x is from 0.05 to 0.65. I take 0.7, I divide by, so it is 0.7. Say for example, we have 1, 2, 3, 4, 5, 6, 7, 8 scale here. So I divide by 8. I have about 0.08. So I take 0.09. So I take 0.09. I add 0.09. 0.09. Then I complete my table. Here's the x-axis. Now for the x-axis, for the y-axis now you have 0.62 to 2.89. So 2.89 is somewhere here. So I take how many reading? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I take 2.9, I divide by 12 and get 0.24. 0.24. So I have chosen 0.26. So you take 0.26, you add 0.26, 0.26, 0.26, 0.26, then you complete your scale here. Now I start plotting the graph. When I finish with the scale, now when you plot a line, a point, you put it a small dot like that, then you put a small circle around. This means that the right answer is somewhere here in the circle. Okay, so this is 1, 2, 3, 4, 5, 6 points. Okay, now what to do? We have to draw a line of best fit. Okay, how to draw the line of best fit? You start by taking the two first point, then see if all the other points are close to the line. If it does not work, you take the first and the third one, you take the first and the fourth one. Okay, then you draw the line. I explain it. You take the first line here and the first point here and second point. You join them. Imagine there is a line here. What are the other points showing? Are they close to the line or are they on the same side? You have to check. If it's not good, you take the first and the third point. You draw a line, then you check the other points. Then the other points are not close to the line. So I have decided not to take the first one. I have decided to take the second one. When I have taken the second one, the third and the fourth, then I have got my best line of best fit. You can see there is one point here on the lower part of the line and one point here on the upper part of the line. So the other points are on the line. So it's a good line of best fit. Okay. Now this point is a bit further away from the point. So you circle it as anomalous point. Anomalous point. Don't forget, never try to trick the graph to try to put the points down. Not good. You always have one anomalous point because when the apparatus, for example, the bulb is too short, we always have anomalous point. Okay. Now we have to draw the gradient. to calculate the gradient. So you draw a construction line. Now the construction line should be 1 minute. The construction line should be in the middle of a line. For example, if this is a square, the small square here, if this is a small square, this is small square, the line should pass in the diagonal. For example, the line cannot pass like that. It's not good. Should pass through the diagonal of the small square here. So the line is along the diagonal here. So I take this coordinate, I put a small arrow here, I put the coordinate here. Can you see the coordinate here? Then I have put here, I have chosen this point because it crosses the small square, the diagonal. So I put the point here, the coordinate. I draw the construction line, this dashed line, all along the length here and all along the length here. This is very important. Okay, now I will use these 2 points, this point and this point, to find the gradient. Now here I have taken the 2 points, and the 2 points I have taken, they are found on the line. Okay, then I take I put x2 y2 here, x1 y1 here. I calculate the gradient. I calculate the gradient become negative 3.4 because the line is like that. If you have a line like that, the gradient will be positive. If the line is like that, the gradient will be negative. So the gradient is negative. Okay, you put the negative here. Now don't forget to put the unit, because how you got this? You have taken y dy by dx, y upon x. So the unit here is s square. The unit here is meter. So x square upon meter. So x square, s square upon meter. So you bring the meter up. It becomes s square meter per. Now the y-intercept. Don't forget that I start with 0. So I can have the y-intercept directly on the graph. It is this point. Okay, it is this point directly on the graph where it cuts the y-axis. So I put the value here. Now I can check if my y-intercept is okay. I construct a line y is equal to mx plus c. I put the gradient in the gradient part here. Then I take a point on the graph. For example, I take for t square, I take this, and for x I take this. Things like that. No, x I take this one, and t square I take this one. Then I replace the values and I check it. It is 2.94. Here on my graph it was 2.91. So it's correct. It's good. Why it's good? Because the small error 0.03, this is no problem. Okay, the experiment is not perfect. There should be an error, human error. Now, for the last part, you have this. You know that the gradient is b, so the gradient is b. It is minus b, so minus b is minus 3.4. So b is 3.4. You bring the unit here also, and for a, the y-intercept, it is s square. So you divide it, x square cut in this, then you have meter on the above, it is meter. So it is 0.86 meter. Now, what does this mean? 0.86 meter. Do you remember h? Do you remember h? Do you remember h? We did not change it, okay? Okay, in this case it was 0.81 centimeter, 0.81 meter, 81 centimeter. So here I got from the equation 0.86. You won't get this. Look at, there is a difference of 0.05. This is not a problem because, as I told you, the practical is not a perfect one, but more or less it approaches a good answer because I got 0.81 and here it is 0.86. So you see how you double check your graph if it is okay. Here also for the y-intercept, I take it from a graph where I cut the y-axis, then I put some values and check if it is okay. Okay, now this is how you do your table. The first part should be larger. Okay, then the other six, for the 6 points here, it is about 1 centimeter. And for the first one, it is about 2 centimeter. Okay, so this is how you draw your graph and enjoy your practical. Don't forget the scale should be nicely but evenly distributed. Okay, and you should fill all your table. Do not fill this one and this one and this one. You fill only the on 2 centimeter scale like that. Okay, don't fill all these points, not necessary, will spoil your graph. Okay, okay, good.